Auzubillahi minasyaitonirrajim. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Hari ini saya akan meneruskan sesi online lecture dengan kursus BQS554, okay, which is Building Services Part 4. In this session, we already move on to the transmission phase of the electricity supply. Let me check. We've already done in terms of the definitions and in terms of the schematic diagrams. Okay, in this, and also in terms of the national grid system. So today we will move on to the transmission components, which is namely the pylon, the transformer, transmission line, and substations. Okay, the pylon or the tower line is basically a lattice steel structure used to support overhead electricity conductors for power lines. These are the towers that carry the weight of power lines which are carrying very high voltage of electricity. Okay, so if we refer back to the grid system, okay, they can carry from 66 kilovolts overhead to 500 kilovolts. Yeah? And this is the image of it. Yeah? So the pylons at which sections of conductor start, finish, or change directions are called strainer pylons. These pylons carry the cables through usually straight lines, but when they have to change directions or they have to from the start of the cable or the end, they are called as strainer pylons. Now these strainer pylons may require anchor wires to counterbalance the weight of the conductors on the opposite side, so that the pylon itself does not tip over. Okay, and also to design to deal with the forces imposed on them. Okay, so the conductors are supported by horizontal strings of conductors. Okay, sorry about the interruptions. There's been a lot of activities around here these days. Okay, so next, okay, the image of the tower line or the pylons, we usually see this all over Malaysia. So know that once you see this tower line or the pylon, it is carrying the transmission line of electricity. Okay, the components of the pylon. Okay, there are numerous components of the pylon itself. Okay, so we can divide it into three components. The top of the pylon, the body, and the footing. The top and body of pylon is the superstructure, whereas the pylon footing is the substructure. Okay, so let's see now. The most top is known as the overhead, okay, ground wire. So this is for ground wire for the entire distribution system. So it runs across a number of pylons. And we have the cross arm, the insulator string, the bundle, okay, and then the K-frame. If you notice that the frame uses a lot of these triangular shapes because it gives the pylon its strength. And then so each of these squares are known as a panel, and then the diagonal bracing, horizontal member, okay, and then goes all the way down as the main leg and the pylon footing. Next, the next component is the transformer. So it's a device that transfers energy from one circuit to another purely by magnetic coupling. So relative motion of the parts of the transformer is not required for transfer of energy, meaning that there is actually no moving components in a transformer, at least for its main purpose of changing the voltage. So they are used to convert between high and low voltages, okay, to change impedance and to provide electrical isolation between circuits. Okay, so we can see here. Now to read this transformer, it said here that this is transformer 132 kV to 33 kV, meaning that from a high voltage of 132 to 33 kV. So meaning that this is a step down transformer. Usually you can find it at the TNB main substation, okay, where the transmission line ends and the distribution line starts, okay, and then this is another one, 33 kilovolts to 11 kilovolts, and this is a further step down transformer. If we look back at the schematics, then we can see that there is a lot of these step down transformers at the end of, or at the distribution phase of the system. So it's called transformers because we need to transform or change the voltage from one level to another. As we have covered earlier, the characteristic of AC current, we are able to manipulate. One of it is the voltage of the AC. So to manipulate this, we use the transformer. So we do this by applying the principle of magnetic induction between coils to convert the voltage or current levels. Okay. So this is a diagram of a magnet which is wrapped with coils. So it is the electrical transformers are a passive device which transform alternating current from one circuit into another circuit through electromagnetic induction. So there must be a difference between the numbers of wrapping of the coils. So they usually are not the same. The wrapping is different between the step up and step down transformer. I'm not sure if it's stated here. Let's see now. I believe it is here. This is supply. If I can find it. Okay, so this is it. So for the step up transformer, usually the primary input winding is a lot less compared to the secondary input windings. So if it's a step down, we have a lot more in its primary input windings compared to the secondary. Okay, so this might be the diagram for a step down transformer. Okay, the primary winding is a lot more compared to the secondary winding. Next component, the transmission line. Okay, basically a medium or a structure that forms all or part of a path from one place to another for directing the transmission of energy. Okay, so the examples include wires, optical fiber, and coaxial cables. Okay, so it's basically a facility that would that would transmit the electricity to the load of a particular area. Okay, and usually the voltage in this transmission line is a lot lower than what is available at the transmission lines. Okay, let's see now. Oh, sorry, it's the distribution line. So what we are talking about here is actually the transmission line itself. So yeah, we are still at the transmission phase. So the transmission line would usually the voltage would be the higher one compared to the distribution lines. And then we have the substation. So it is the part of an electricity transmission and distribution system where the voltage is transformed from low to high and vice versa. So usually we can find this step up or step down transformer in a facility known as the substation. So the transformer is not like a freestanding structure. It is a part of that substation. So the substation has a step-up transformer, okay, or a step-down transformer, and many other equipments. Okay. So in terms of transmission, the major player is TNB. So TNB generates and distributes the electric to premises and range of business activities. When they say generate and distribute, it also includes the phase of transmission as well as supply. Okay, so the terms being used here is loosely defined. Okay, So we have to be a bit alert on that. So the electricity is, see, it's written here is supplied. Usually, yes, that's not the term that we are going to use. The correct word to use is generated lah. So the electricity is generated from the generator station or power, and then it will be transmitted through the tower line, through the transmission lines. Okay, so this is the PMU, pencawang masuk utama. This is the main substation for that particular area. In this case, we have pencawang masuk utama at Lumut Maritim. So what does this PMU does? It is basically a step down transformer facility. So it takes in 132 kilovolts, and then it would step it down to 33 and further step it down to 11 kilovolts. Okay, so this PMU will transmit the electricity to factories, business, houses, and etc. through overhead lines and underground cables. Next is trunking. Okay, so from the transformer, the flow of the electricity entered into the PMU to trunking or underground cables. Okay, so that this is basically inside the PMU itself. Okay. And then this is the control panel in the PMU. So the current from transformer through the trunking will be controlled by the control panel in the PMU. So this is where the staff of TMB will be able to monitor the activities of the facility. Okay. So in this case, the Lumut Maritime Substation. Okay. And in some cases, they are also able to monitor the parameters of this substation at the main control room at the TNB HQ. So some of them, they are able to just monitor, and some of them, they are able to monitor and have a degree of control of the control panel. Okay, this is done through their network system. This is the vacuum circuit breaker for 33 kilovolts and 11 kilovolts. So as the name implies, this circuit breaker will engage when there are problems at the substation. Okay, and avoid damages to the equipment of the consumer, especially in terms of over voltage, things like that. Okay, so this is the control panels for the 33 kilovolt and 11 kilovolts. So from the circuit breaker, the current will flow out to the electric pole. So this is an overhead line. Okay, so the electric pole will carry a 33 kilovolt overhead power line. Okay, and then to PPU near the PMU. Okay, so the PPU is pencawang pembahagi utama. Okay, let's see, the PMU is pencawang masuk utama. So this is the main substation, and then the PPU is the secondary substation. So we can see this PPU is at I tower. So it takes in very blurry here, 33 kilovolts, and step the voltage down to 11 kilovolts. The PMU, okay, so it has both outputs. It can produce 33 kilovolts and it also produces 11 kilovolts. Most likely the 11 kilovolts will be for the customers at Lumut Maritime area, whereas customers at other further area, they will supply 33 kilovolts to the area's PPU. Okay, PPU, and then that area PPU, in this case Itawa, will take that 33 kilovolts, and then only then they will reduce the voltage to 11 kilovolts. So they need the 33 kilovolts in order to distribute the electricity through long distances. Okay, so in the PMU, a battery is needed for safety and security. Placed in a room which the battery is used to ensure the flow of electricity is in good condition if any emergency case happen. So the battery is switched on 24 hours non-stop. So they have to ensure that let's say in an event of a blackout, especially a large scale blackout, the substation will continue to operate from the power supplied from the battery. So this is very important. Okay. Okay, so this is just some photos. Okay. So operation electricity is transmitted to PPU after the electricity is distributed to PMU. So it goes to PMU first and then it goes to the PPU. So it will reduce from 33 to 11 kilovolt at the next distribution process, at the next area lah. So people at the Lumut Maritime can directly take 11 kilovolts from their PMU. Where people living other areas, they have to use their PPU unless their area have another PMU. Okay, and then the current flows are transformed by transformer and control panel. Okay, we have seen that. Transformer will reduce the voltage. Okay, and then the current will be transferred to the VCB to be distributed to the substation. Okay, VCB is the vacuum circuit breaker we mentioned earlier. Okay, so at the PPU we have the transformer, we have the control panel for the incoming 33 kilovolts and the outgoing 11 kilovolt. We have the vacuum circuit breaker, we have the battery for power supply and the charger box. Okay, so this is 33 kilovolt step down transformer. Control panel, you can see the I'm not sure if you can see it, but this is for 33 to 11 kilovolt transformer 1, and they have two 33 to 11 kilovolt transformer number 2. Okay, this is the control panel for 11 kilovolts. Okay, vacuum circuit breaker for 33 kilovolts. Okay, circuit breaker for VCB for 11 kilovolts. This is the charger box, and of course the batteries. Okay, this is another a smaller scale substation. Okay. So after the distribution process in the PPU, so from PMU to PPU, and then the power will be delivered to the nearest substation. This thing. Okay, so we can usually find the substation at let's say housing area. Okay, we can find this, or as a part of high-rise buildings, they would have their own substation. Okay. So the current from PPU is 11 kilovolts. Now this substation has a transformer in it. It will reduce the current from 11 kilovolts to 415 volts. Okay, so and then the 415 volts will be transferred by outgoing unit to feeder pillar. And then these 415 volts shall be distributed to consumer for those consumer who consumes 415 volts. So in this substation, the components include step-down transformer, 11 kilovolts to 415 volts, switchgear, high voltage fuse unit, okay, for in case there is issues. So and then outgoing unit and the feeder pillar. So this is the switch gear, the step down transformer from 11 kilovolts to 415 volts. As you can see, the transformer is a bit smaller. Okay, this is the outgoing unit and the feeder pillar. Feeder pillar, we can find it usually at the side of the road. Okay, this is this small box. So the feeder pillar is basically like a mini substation because it receives 415 volts from the substation and reduce it further to 240 volts for the end user. So this is usually the residential type of users, a bit of commercial like shop lots and things like that. So they use a very low voltage electrical supply. So the method used to transfer the total current 240 volt is single phase system by overhead cable. So they are supplying 240 single phase. Okay. So for three-phase system, the current is directly sent to the building by the feeder pillar. Okay. So normally the current of three-phase is larger, which is always used for building consume larger current of electricity. Okay, alternatively, the 415 volt can also be distributed by using overhead cable. So in terms of this feeder pillar, it provides a lot of electrical supply. It provides electrical supply like 415 volts, but it also supplies 240 volts in single and three-phase system. Okay. Okay, so this is the overhead electric pole, and you can see the feeder pillar over here. So now we are at the distribution system, and we've been in the distribution system for quite a while. So it is process, excuse me. Process of transmission of electricity from major load centers to consumer. So power is further distributed to load center substation where the voltage are further reduced before reaching factories. Of course, they have to reduce it to 240 volts. So in this distribution system, we can see that the phase would start at 33 kilovolts and it reduced all the way to 240 volts. Okay, so this is the distribution system schematic, if you want to call it that. Okay, so it will start from the step down transformer at the PMU to the PPU, okay, all the way down to the feeder pillar of 240 volts. Okay, so that is on the transmission lines or the transmission phase. Next, let's see. We have a look at the supply. So this is the fourth phase. If you can remember, we have generation, transmission. We've just talked about distribution. Now we are at the supply phase. Okay. Let's see. So the supply system. So the supply system, we are talking about to the consumer or the end user. We do not need to repeat this. We already talked about this early. Okay, so this is okay, we mentioned this. So the diagrammatic installation of single phase for single unit dwelling. So we have the external supply and the internal supply. So the supply to domestic building can be of two forms, or we can supply it through overhead cables or underground lines. Okay, so the domestic buildings are supplied with single phase supply, contains a live phase and a neutral in one cable. So it has two lines. Okay, a single phase supply has two lines. One is for live, the other one is for neutral. Whereas if a three-phase supply would have four lines, so three lines is for live and one line for neutral. So terminating at the meter board. So we'll start at the substation and then we send the external ends at the meter of the building itself, whether a house or a shop and whatever. So the responsibility of TMB ends here, just before the meter of the actual building. So anything which is after the meter of the building, meaning the internal supply, is the responsibility of the building owners themselves. Okay, in terms of installing the meter, they have to ask from TNB. Installing the distribution board, is installing the power circuit, and all that is the responsibility of the building owner. So we can see here, temperature will step down. So we have already stepped down to 1 kilovolt. Okay, so this is the supply phase through overhead or underground, and then the consumer phase is, it can be considered of the part of the supply. So the consumer consumes, this is the typical consumer lah, not the large size consumer. They will consume 415 volts, some of them 600. Okay, this is quite big, but normally 415 and 240. So this is a diagram of an overhead power line. I don't think in Malaysia we use this kind of design, but it is somewhat similar. just to show you the connection. So for an overhead power supply, we have the distribution line itself, where each of the building will make a connection point to the distribution line. This is where they will take in their electrical supply, and then it will be sent to the main switch of the house. Okay, and they have all their fuses in there and into the electrical circuits of the building itself. So in terms of this is very useful, a consumer supply system. So which type of consumer consumes what? Okay, so this is for generation and distribution. 33 kilovolts, large or heavy industry, cities, towns and railway. So they use 33 kilovolt of 3-phase supply. 11 kilovolt for light industry, hospital, towns and villages. Again, 3-phase with 3-wire cable. Okay, 400 volts, small industry, offices, farms. 240 volts. This is 400 or 415 lah. It's about similar. 240 or 200 is for houses, schools, small commercial premises. Okay, normal supply from TNB. Okay, this is already being mentioned. Standby supply, genset. This is for specialized buildings lah, where they need continuous power supply. Okay. Next is 3-phase supply system. Provides 73% more power than single phase. So if let's say your house consumes a lot of energy, you have like an aircon for every single room of your house, then maybe you need to upgrade the wiring of your house from a single phase to a 3-phase system. Because in a 3-phase system, we have 3 inputs and 1 output. You can see from here, we have the first wave, the first loop, okay, and then the second phase and the third phase coming in. So we have a lot more what you call current coming in. Okay. So for a 3-phase wiring, you can see that it has the 3 fuses and 3 color wires. All these 3 wires are live wires. Okay, the neutral is somewhere inside, I think. Okay. So some newer houses come with 3-phase wiring already. I'm not sure. It depends on your developer. So if your developer would supply your brand new house with a 3-phase, then that is excellent. Okay. So for metering is a meter for measuring and recording the quantity of electrical power consumed with respect to time. So this is how the TNB charges the consumer. So the meter circuit consists of 2 coils, the current coil connected across the phase and a voltage coil connected across the phase and neutral. So this is the metering. This is the old type of metering unit. It is very analog type. These days we use the digital metering. Okay. Yeah. In terms of the distribution of electricity inside distribution for large and high-rise building, we have 3 types: radial, ring main, and rising main. So the radial system, let's have a look at the diagram. So this is the radial system. So we have a substation here, and from the substation will be sent to each and every single building with 400 or 230 volts supply. So the electrical supply radiates from the main intake panel, consists of main switch connected to fuses through a bus bar. This is inside the substation itself. So several separate cables are run from the main intake panel to subsidiary distribution panel, which may be situated in separate building or strategic points in one building. So from the substation, it will be sent to the intake panel of the customer's building. So example of using a radial system are factories and resort complexes. So they have one dedicated line to each of the building. Okay. Next is the ring main system. The ring main system looks like this. It's like a ring. So in case for large development, the scheme having several buildings around the perimeter of site, the ring circuit is provided. So the ring main circuit will be taken around the site into each building. The advantages: each building and individual section may be isolated without switching off the entire installation. And the current flow from either direction can reduce voltage drop. Okay, so from the substation, it will be sent through this ring cable, okay, from one building to another. Okay. Next is rising main distribution. This is exclusively for high-rise buildings. So for buildings 5-story and above, normally preferable to pass conductor vertically through the building. So this is the vertical conductors is known as they will pass through what is known as the riser. So the supply of each floor is connected to the rising main by means of tap-off subsidiary units. So this is an example. So this is the incoming service cable, which is usually located underground or at the service level. So from here we'll go to the supply cutouts into the into meter and the fuse. Okay, it's all located here. And then from there, each level will tap their electricity from their fuse board. Okay, the fuse board will be connected to the this rising main. Okay. So a domestic supply. So for domestic building, the supply is AC single phase 240 volts. So in Malaysia, we are using 240 volts. In some places in the US, they are using 110. Okay, so consumer board serve individual circuit. So the circuit, what type of circuit you use depends on your building. Depends on the decision of the owner. So the fuses is inserted to protect each stage of the distribution. So if there is an over voltage, the fuses will break the circuit, and no more electricity will be sent through the circuit. Earth ensures the circuit fuses casing becomes on. So earthing is required to pass the electricity to the ground. And then we have switches. Okay, that's typical. This is a 3-phase supply for buildings. Okay, so from the transformer 415 down to 250 240 volts, and from there we have the transmission line, 3-phase supply, whether it's overhead or underground lines. And then from there, the supply will be sent to each consumer. This one as a single phase supply. They can also be sent as a 3-phase. Okay. So the consumer power supply control unit. So now we go to the control unit itself. We have a diagram. This consumer unit, what we usually call as the fuse box. This thing. So every single building will have this consumer unit, or known as the fuse box. So it is all the circuits in that particular building comes together in these circuit boxes, where all of the circuits fuses are located in this control or consumer unit lah. So at this consumer unit, we can trip the fuse in order to isolate certain circuit of the house to do maintenance, repairs, and whatnot. So the location of the unit as close as possible to the metering unit, but usually at the inside of the building. So the metering unit is usually outside because the TMB people needs to look at the numbers to charge you, but the consumer unit is located inside the building, but not too far from the meter itself. Okay, circuit projection is by semi-enclosed wireable fuse. Okay, cartridge fuse or miniature circuit breaker. Alright. So inside this consumer unit, I'm not suggesting you open this consumer unit, but as just for your general knowledge, there is a you call a phase or a live bar between the fuses and isolators. So there's a bar that would carry live electric. So don't to open this consumer unit by yourself. Okay. So this is an example. In this building, they have 6 fuses, maybe representing 6 circuit in the house. So this is from the supply. So this is cable, and then we have the main switch, 2-pole switch, and then this is the bar, the bus bar, which connects. We can connect 1, 2, 3, 4, 5, 6 circuits. So the first circuit is for lighting. So lighting, you usually require very low voltage, so very low amp. So we supply with 6 amp for lighting. So they have 2 circuits of lighting here. So we provide 2 fuses, 16 amp for heater. Heater would consume a lot more electricity, so we put 16 amps. 32 amp ring main, so this is a lot bigger. So we have 2 of those, and 45 amp for cooker. Okay, so this is another example. This building has 1, 2, 3, 4, 5, 6, 7, 8 fuses for 8 separate circuits. But they also have 1 as a spare, so which is a good thing. It's always better to install a larger consumer unit where you can put in spare fuses for future renovations. Okay, so this is a good diagram from the main supply. Okay, so to the meter, yes, the meter is responsibility of TMB. All right. And the ELCB, electronic live circuit breaker, this is the responsibility of consumer. Okay, the main switch which provide electricity, we only have 4 fuses here plus 1 as a spare. Okay, so this is another example of distribution panel. So intake, most domestic supply in Malaysia are overhead. It's not like the overseas. We have a lot of overhead intake for electricity compared to underground. Okay, so this is a diagram for underground intake. Yeah. And then this is another diagram for electrical distribution system. Okay. Okay, for supply to larger buildings. So for larger building, they will take like 11 kilovolts directly because that building has its own transformer. Okay, so that building will take in 11 kilovolts and provide 415 and 240 volts. So they will have their bus bars in the distribution board, 3-phase individual supplies, and 3-phase rising bus bar. Okay, we'll go through one by one. Single phase power and light circuit, as we said, for power consumption and lighting doesn't require too much energy, so we would usually use single phase for them. Okay. So this is for high-rise large buildings served by underground 11 kilovolt ring main from substation. So this is from the substation and then being sent underground to this, okay, where this is a bus bar chamber. So we have three copper phase bars, 1 neutral. So we have 1, 2, 3, 4. Okay, 3 live and 1 neutral. And these are all bus bar. They are not cables. They are pieces of copper. Because they would last a lot longer. And usually they are exposed. So nobody is supposed to touch them, or nobody is supposed to open up this box when the electricity is in service. So from there, for the services that require a lot of electricity, such as ventilation, boiler, and whatnot, they will take directly from this. What do you call it? Yeah, I guess it's their own distribution panel. Yeah. Okay, so from their distribution panel here, so they take directly, most probably at a higher voltage. So from there, they will send the rest. They will step it down, maybe. Okay, let's see now. 3-phase sub vertical isolated. There's no voltage here. No, it is all down to 240. It's all 240 volts. So it's from 415 to 240. So once it goes in here, it's already 240 volts. So these 3-phase supplies are being sent to the ventilation and boiler plant. Okay, because they use a lot of energy, so they use 3-phase. 3-phase 240 volts for their boiler, for their air conditioning system and whatnot. And then goes to the next level. This is Three-phase supplies can be tapped off to more remote distribution board. So this is another three-phase 240 volt supplies for other services of the building. Or for areas of the building which is far away from this riser. Okay. And for other levels, they go upwards through a rising bus bar to supply electricity to each floor, and each floor would have their own this circuit board. Okay. So from here, from the three phase here, they would switch into single phase, where each of these connection will connect one live and one neutral. This is one live, one neutral, one live, one neutral. So it is a single phase. So single phase light for lightning circuits, okay, 5 or 10 amps, okay. Single phase power circuits. For your what you call PowerPoint. Okay, so down here is three phase. Okay, here, and even the rising main. But once it gets to this fuse box that serve each of the floor, they will change it to a single phase. Okay, so you can see here, this is the bus bar system for, I believe this is a rising main. You can see it's all pieces of copper that move upwards. Okay. So it's in electrical power distribution refers to a thick strips of copper or aluminium that conduct electricity within a switchboard, distribution board, substation, or other electrical apparatus. So the size of the bus bar is important in determining the amount determining the maximum amount of current they can be safely carried. So the bigger the size of these strips of copper, the more voltage it can handle. So if you are talking about just 214 volts, maybe the size of this bus bar won't be that big. But if you are talking about 415 and higher, then you would have a thicker and larger cross section of the bus bar. So it's rectangular, it's a sheet metal. So for 4 metal strips, okay, so since this is three phase, so it has 4 metal strips, red, white, blue, and black. So 3 live, 1 neutral. Okay, and then okay, this is the same rising bus bar. It can be used to distribute 415 volts three phase. 240 also can, no problem. So it needs a vertical ducting or a riser to serve the entire height of the building. And to prevent the spread of fire, each of the fire barriers needs to be installed, okay, at each compartment of floor level, meaning that over here we need to put in the fire barrier. Here also we need to put the fire barrier. Okay, so with that we have finally completed our, I believe, chapter 2, is it? Yeah, chapter 2. We already done our fire chapter, and then this is the electrical chapter. So it's been a pleasure to be presenting you this slide to you. Any issues that you have, you can always contact me in whichever way, or you can message me through Facebook and whatnot. Since we already have the percolating UITM saying that UITM system will be closing until the end of the month, the classes will not be conducted during this period. What's happened after that, I guess we have to wait for the instructions from the administration of UiTM. Okay, so until then, I wish you all the best. Yang balik kampung tu sila berhati-hati and try to keep yourself away from crowded places. Keep yourself and your family safe from this outbreak. Okay. Okay, terima kasih semua. Assalamualaikum warahmatullahi wabarakatuh.